So in this video, we're going to look at resolving an indefinite integral and then using it to find what's called a particular solution. So it says find the antiderivative of f of x equals 9x squared plus 4x plus 4 that contains the point input 1, output 10. And the idea here is when we find an antiderivative, we always had to add that constant of integration on that, plus c, because we get a family of functions, vertical translations of a function, all of which have the same derivative. And when we're finding a particular solution, what we're really saying is we want to find the specific antiderivative that behaves in some given way. And that means that we're going to have to be provided some additional information, and that's what this point is right here. So step one is just to find the antiderivative. So we have the function f of x equals 9x squared plus 4x plus 4. We want to calculate the antiderivative, which we've been naming big F of x. And we get the antiderivative by taking the antiderivative of the function, the antiderivative or the integral of f of x dx, which means we need to integrate that polynomial 9x squared plus 4x plus 4 dx. And I think it was video 3 where we looked at how to integrate a polynomial. We take advantage of the fact that the polynomial can be broken apart into pieces. So this first term, 9x squared, is really 9 times the integral of x squared dx plus, there's that constant multiple times x, so we get 4 times the integral of x dx plus a constant 4 times the integral of dx, and then we just integrate. So here we're going to get 9 times, we have x squared, so we're going to increase that exponent by 1 to a 3, and then we need to multiply in the coefficient position by the reciprocal of the 3, plus 4 times, this is x to the first, so we're going to increase the exponent by 1 and multiply by its reciprocal to kill that 2 when we differentiate, plus, and the integral of 1 dx is just x, so here we get 4 times x, and it's plus a constant of integration because there are infinitely many functions whose derivative is 9x squared plus 4x plus 4, and they all differ by a constant of integration. And now we want to simplify a little bit. So we get 9 divided by 3 is 3x cubed plus 4 times a half is 2x squared plus 4x plus c. So there are infinitely many functions whose derivative is f of x. And what we're after is the specific antiderivative that contains the point 110. So all we need to do here is recognize that we're being given the antiderivative output of 10 when the input is equal to 1. So we plug that information into the antiderivative function. So I replace f of x, big F of x, with the 10 equals 3 times, and now everywhere we see an x, we replace the x with a 1. So we get 1 cubed plus 2 times 1 squared plus 4 times 1 plus the constant of integration. And we solve for the specific constant that goes with the function that contains that point. So we get 10 equals, we have 3 times 1 plus 2 times 1 plus 4 times 1. So we get 3 plus 2 plus 4 is 9 plus c. And then we subtract 9 from both sides, we get 1 equals c. So the specific antiderivative that we're after is the antiderivative f of x equals 3x cubed plus 2x squared plus 4x plus c, but c is equal to 1. So we go plus 1, and that is the particular solution. So again, a particular solution is just going to be what you get when you find the antiderivative in terms of the constant of integration, but then you have some additional information that lets you hone in on a specific antiderivative.